Hi and welcome to Unit 2, Topic 2, Video 20. And in this video we're going to finish our lesson on modulus functions by solving modulus equations. So we've got some examples here in the general sense. If the modulus of f of x is equal to k, f of x is just some function, well it means that f of x must be equal to positive or negative k. That's a really simple approach to these equations to start with. But it also means that if the modulus of f of x is less than k, then it means that f of x must be between negative k and k. In the last video we explored a couple of simple cases like this. Of course there's a reciprocal to that, or an opposite to that. If it's greater than k, well we get the f of x is outside of that domain. It's less than negative k or greater than k. That's what we're dealing with there. So let's consider it graphically as well. I've got a function here. The absolute value of x squared minus 3x equals 2. Well, that means that x squared minus 3x is equal to 2, or x squared minus 3x is equal to negative 2. Now, I've done some fun stuff here, and you may want to pause and have a look at how I've solved these quadratic equations. But it's telling you there's 4 solutions to this equation. There is the 1 and 2 that come from the easy solution, where it's equal to negative 2. But there's also this into the quadratic formula. There's the exact value, and the unexact values are that negative 0.562 rounded, or 3.562 also rounded, and you can see where these apply. So here's our negative 0.562, and here's our 3.562, and then of course there's our other more easy ones. And you can see that these two occur, so the ones highlighted yellow occur there, and they occur when the function was positive, because we're letting the function equal positive 2. The other two, in green, here and here, they occur there, and they occur in a bit of the function that we've transported or reflected from down here, because they were negative, and hence that's when they're equal to the negative 2. So there's a really interesting result there. Let's have a look at example 3, and this will finish our modulus work. So we're going to solve a couple of equations. The first one is x squared minus 10x equals 21. But it's the modulus. So, A, the modulus of x squared minus 10x equals 21. Well, we can solve that pretty easily by just saying either x squared minus 10x equals 21, or x squared minus 10x equals negative 21. Now 7 and 3 are a nice pair that add to 10 and multiply to give 21. So one of these two is going to work out nicely, but I'm not sure which one. Or perhaps both. Minus 21 equals 0. And so can we factorise this? Negative 10, get negative 7, negative 3, that doesn't quite work. So I might actually start over here, because I'm feeling a little bit lazy. Minus 10x plus 21 equals 0. I believe this one works better. X minus 7 and x minus 3 equals 0, giving us x is equal to 3 or 7. So that's a nice solution. So now let's have a look at the other possible solution, which is less nice, and we'll take this to an exact value. So then we get this one where x is equal to negative of negative 10 plus or minus the square root, I'm building into here now, negative 10 squared minus 4 times 1 times negative 21 all over 2 times 1, so just 2. And that's equal to 10 plus or minus the square root, and this is 100 plus 84, so the square root of 184 over 2, and 10 divided by 2 is 5, plus or minus 184 does divide by 4 to give 46, so plus or minus the square root of 46. And there doesn't seem to be much else we can do with that. There's no square number factors of 46. There's our solution, and we can work out what that is valued at if we want to. So there's our two solutions there. Now let's have a look at B. So B is the 2, and you can see that they're going to, I've deliberately chosen these examples to build us up. What happens if we have that modulus function on the inside? So we start with 2 to the power of modulus of x equals 16. Now, in this case, let's treat it like we're not dealing with the absolute value yet. It's just modulus x. We'll just leave it there. And we get this. The modulus of x is equal to log base 2 of 16, which of course is equal to 4. 2 to the power of what equals 16? That's 4. So the modulus of x is equal to 4. And if the modulus of x equals 4, then x is equal to plus or minus 4. And equivalently, 2 to the power of the modulus of x equals 17 gives us exactly the same thing. Log base 2 of 17, so therefore x is equal to plus or minus log base 2 of 17. The only difference being this time, we don't get a nice number like 4. We've got log base 2 of 17, which is about 4.09. So there's a couple of solutions. They won't go much beyond that. It gives you a start on how to deal with these types of equations. Get it down to the fact you've got an absolute value of everything on one side and everything else is on the other side, and then split it into the positive and the negative case and solve from there in two separate equations. All the best.